Year 9s again. This time we're going to talk about the null factor law, okay? So this is obviously quadratics again because that's what we're doing. So the null factor law tells us what the x-intercepts are, okay? That's actually what we're finding out. So we're going to find out different answers for what x could be. And remember, x-intercepts are where the graph crosses the x-axis. So this is your x-axis obviously, and this is your y-axis. So these 2 points are going to be what we're finding out using the null factor law. Sometimes x will have one answer, like if it did this. If it only touches the x-axis, it'll have one answer. Sometimes it'll have 2 answers, and sometimes, let's do this, the graph will be up here and it won't actually touch the x-axis at all, but we're not going to do that for now, okay? We're just going to talk about how to find out what x could possibly be and what the x-intercepts are. Right, so there's a couple of different types of ways that the formula might look. To begin with, we might have something that looks like this. Okay, now the null factor law tells us that we're going to make y equal 0. Okay, so instead of y, we're going to do 0. Now this actually makes a lot of sense based on what we did earlier with our linear graphs. Because if you think about it, when y is 0, so when y is 0, because this is along the y-axis, that is our x-intercept when y is 0, because it's not up and down the y-axis. Exactly the same idea here, okay? But this time we might have multiple answers for x. So let's have a look at what this could possibly be. Oh, let's not do that. So x is, we don't have to do any more steps for this one. So we're going to have a look for this equation to be true. For x bracket x plus 2 to equal 0, one of these 2 bits, so either this bit or this bit, needs to equal 0, because anything times 0 is 0. So one of these 2 answers must be 0. For this bit to be 0, well, guess what? It's got to be 0. For this bit to be 0, x needs to be negative 2, because negative 2 plus 2 is 0. Now the easy way to say this is the answer to this bit is just going to be the opposite of whatever this number is. So if it was 8, x would be negative 8, because you need this bracket to equal 0, okay? So if we had this, x minus 4, so if we had that, x would be 0 for this one, and for this one, x would have to be 4, because 4 minus 4 is 0. Okay, so that's how we figure out what x could possibly be. So if we drew it like this, our graph would look something like that, with this being 4, and this is obviously 0. Okay, so same with this one. If we did this one, it would look something like that. This would be 0, this would be negative 2. That is what this is telling us, okay? So this is one of the ways we can use the null factor law to find the x-intercepts. Now, what if you had something that looked more like this? Let's say x plus 2, x minus 4. Okay? So what we do is we say one of these things, either this or this, has to equal 0. Oh, actually, 0. Okay? So one of these 2 brackets must equal 0 for this equation to be true. So if it was this one, x would have to be negative 2, because negative 2 plus 2 is 0. And for this one to be true, x would have to be 4, because 4 minus 4 is 0. So it would look something like this. This would be 4, and this would be negative 2. Okay? So this is one of the other ways. What if we had y equals x minus 8, x plus 8? Okay, we make this 0. So for this to be true, x needs to be 8. And for this one, it has to be negative 8. So we would have a graph that would look, whoops, why did I draw it like that? Let's get rid of that. That's very silly of me. Okay, to draw it like this, it would look something like this. This would be 8, and this would be negative 8, okay? That's what we're finding using the null factor law. So x could be 1 different value, x could be 2 different values, x could be nothing at all. But for now, we're sort of working with a couple of different things, all right? So that is how you use the null factor law. Now, sometimes you will have to, so this is really quite nice because they've given you brackets. Sometimes you'll have to put the brackets in yourself, okay? So let's say, for example, you have 2x squared plus 4x, okay? Now, what are your common factors? Remember, the first step in factorizing, which we did earlier in the year, is to find your common factors. If there are none, great. If there are, let's take them out. So 2 is common to both of these. There is a 2 here, and you can also divide this by 2. There is also an x in both of these, so let's take it out. Now, what we're going to do is, this means because we've taken it out of the brackets, we need to divide both of these terms by 2x. Well, we've got an x left here because there's no more numbers, and x squared really means x multiplied by itself, doesn't it? Some people were saying, oh, you just leave a squared, that's what's left. There's no such thing as a little squared by itself. All that means is x multiplied by itself. So we've still got one of the x's left. Now what have we got left here? We've got a 2 left over because we've divided 4 by 2, so 2 is left, and we've taken out the x. Okay, so now we can figure out what x would equal for this to be true. If it's here, x has got to be 0 again because 2 times 0 would be 0. And inside the brackets, x has got to be -2 because -2 plus 2 is 0. So this is the same step as before, but if you can, you must take out a common factor first, all right?